say.
Okay, thank you. Well, I entitled this demonstration, Piercing on the Cheap. And what we're going to be doing is learning how to do something like this. Actually, I'm going to be showing you how to build the tools to do something like this, and then, time permitting, we'll do a little bit of piercing, transfer pattern and piercing. How many of you have looked at thin wall turning, piercing, carving, pyrography, and said, I can't do that. That's beyond me. I think everybody just about has. It's not beyond you. You just need to take the initiative and do it. These are some of the things I have pierced. And what I like to do is the thin wall piercing, where you turn the material down thin, about 60 thousandths thick, 1/16 of an inch, maximum 0.09 thickness, and then do the fine work using the dental tool. Now, you can turn thicker material and pierce it using a heavier duty piercing equipment. It's not what I like. I prefer the finer work, whether it's the filigree like this or the outlining. This type of work where it's solid pierced holes in it with no outlining. But come up and during the break and take a look at any of these you like. But back to the question about, right in the middle of the screen, back to the question about you looking at something and say, I can't do that. Well, here about a month ago, I saw a quotation, and it's was by a Frenchman named Guillaume Apollonius or something like that. I just completely ruined the name. But it goes something like this. The man said, come to the edge. And I said, I'm afraid. The man said, come to the edge. And I said, I might fall. The man said, eventually, come to the edge. And I did. And he pushed me, and I flew. It's easy to do. Go to the edge. I'm hoping this will be a little push you over the edge, and go and do it. Practice it. It's a lot of fun. Anybody can do it. If I can do it, anybody can do it. Okay? Okay, and I'm going to try to do this because this is what they tell me to do at SWAT, to repeat the question. So if I don't, please remind me, because it doesn't get recorded otherwise. The outside rim of this piece is thicker. It can be whatever you want, but it needs to be this way normally for stability. If you're piercing this fine all the way around, you need the stability and the strength of this. Now, there was one picture in the ones that were being scrolled through earlier that did not have a thick outer rim. It was pierced all the way to the edge. I didn't bring it because it is so fragile, absolutely so fragile that there's no way I would bring it. It's in a cabinet, and that's it. Now, these are, like I say, these are some of the ones I've done. I do have one back here, though, that is, I consider it my best one I've ever done. I don't put it out because, again, it is very fragile. This one's got turquoise inlay. It has copper leaf. It's finely pierced, and it's broken. Neil, I thought you taped this thing down. Oh, thank you. Let's see, that's the fourth time that's been broken. I cried when I broke it the first time, believe me, because I did have a lot of work in that. Don't worry about it. I've got some more pieces I can glue back in. But, it was originally a pretty nice piece. I was putting the first coat of finish on it and dropped it on concrete and it just shattered. That's the last time I will use sycamore. Sycamore really seemed to be real brittle.
What do you prefer?
Maple. Mm-hmm. Maple works good. I've done burls. I've done elm works good. Of course, our standby. No, it's a mesquite. But I really did have a problem with sycamore. Okay, let's talk about piercing tools. Most everybody has some version of a Dremel tool, whether it looks like this or just a cylindrical one, battery powered, whatever. This could be used for heavier wall piercing than this, thicker material. It doesn't work real well with this because the cutters are too large, the ones that you can get. If you can chuck the little cutters like we're going to use later, but this doesn't turn fast enough. 25, 30,000 RPM. If you go to a micro motor system like this, same story. This turns maybe 45 to 50,000 at the most. Too slow for these little cutters, way too slow. We're talking about 350 to 400,000 RPM on the air-driven turbine cutters, hand pieces. So I've looked around and I've been doing this for about 8 years now. Originally, the tool that I used was this one. This is just a dental tool. Look at it, the head is at 90 degrees. It uses a chuck key to change the cutter. It's extremely difficult to use. It's the angle of it is all wrong when you're trying to come in here and pierce. Just in the last couple of years, these have become available. These are a 45-degree angle. They also have available LED lights. There's a little generator inside here. Pass that around. That generates a little voltage. It's air-driven right off the main airstream and generates a voltage for the LED light. They're worth the extra price that you pay for them. Now, I do a lot of shopping on eBay. These are extremely expensive, about $50. So they're cheap enough. The question was, do they come out of China?
Are they new?
Yes, new. Yes, they are new. They're not used. Is that what you mean? Yeah. No, they're new. Now, one thing is, if you cruise eBay and look for these, if you look on my handout, you'll see different links and different search words that you need to use in your search. One of the things that you've got to look for is ceramic bearings. The ceramic bearings do not require lubrication. If you don't have the ceramic, if you just have the standard steel bearings, you need to lubricate these about every 20 minutes. And then you're going to get oil on your turnings, and you don't want that. Ceramic bearings will last as long as you don't overspeed them, and we'll talk about that a little bit more later. But Inside this unit is a little turbine that looks like that. It's a little turbine just similar to what's in an airplane jet engine, powered by air through a scroll, and it spins, like I said, at 350 to 400,000 RPM. There are a couple different kinds of chucks available. You've got a push button, which is, let's see, can you get that? Okay, this has the push button chuck, which I was originally told would not hold the cutter very tightly. I have found out that it seems to hold perfectly well. So that's one of the things that you're going to look for is a push button chuck, or the alternative is one like this that uses a, where'd it go? A little key or a chuck wrench that goes over the unit like that, and you turn it to unlock the chuck. You put the burr back in, you turn it down to tighten it. This does hold real tight, so you don't have to worry about your burr coming out of the tool.
Called the push button?
Push button.
Push button.
Chuck. Yeah,
Whole thing I'm looking for.
Okay. Oh, I'm sorry. The whole thing, the question was, what do you call this whole thing? When you search for it on eBay, and that's where I get all mine, you'll search for handpiece. In this case, 45 degree, because for the dental type handpieces, that's the best one I found, the best angle. Ceramic. And if you want the LED, they cost a little more, but they're well worth it, in my opinion. So if you search those items in your search engine, and you'll come up with a series of them, and they'll be priced anywhere from $50 up to $115, $120. They're all essentially the same item. Now, some of them are going to say NSK, which is a big brand name of handpieces, made in Japan. They lie. These are all made in China, the ones that are in on eBay. To my knowledge, NSK does not make a 45 degree handpiece. Okay. Now, one thing I found, if you've got any arthritis in your hand, it's real handy to wrap foam around them. If you don't have a heated shop, it's really handy to wrap foam around them, because air expands through here and through the turbine, and this thing will get cold. Vibration is not a problem, but it will get cold, and it's just easier to hold if you have that around it. Okay, now I mentioned NSK. The professional, you might say, handpiece, and the easiest one to use is straight, like this. The problem is, you don't find these coming out of China. I have not found a single straight, high-speed handpiece. Now, you can find low speed, but you're talking about 50,000 RPM again, but not the 400,000. This particular handpiece is $400. I'm talking about having the regulator, the handpiece, the hose, everything for less than $100 as a starter. If you want to upgrade to this, it's a simple matter. Unplug the old one, plug the new one in, and you're running. Now, this is kind of an intermediate price. There is one that is lower. It's smaller. It's made out of plastic. It has a plastic turbine in it. It comes apart, from what I've been reading. Messes up the bearings, and it's around $300. There's a couple that are more expensive, up around $500, and there's another one that's about $700 and some odd dollars, very similar to this one. So right now, for the higher powered straight handpiece, this NSK Presto is probably about the best one you're going to get. Okay, so having said that, what does it take to power these? Well, it takes some air. It takes about less than 2 CFM at 35 pounds per square inch. The best thing you can do compressor-wise, the least expensive, is 2 CFM, about 60 PSI. So a lot of your little squat compressors like you see at Harbor Freight and places like that will work fine. I've got a little one back behind the door here that we're going to use later, and it'll run, it'll cycle. It'll run for a minute, and then it'll cut off, and then it'll start running again. So the larger compressor you have, and I imagine most everybody here has a compressor, the larger the better. The larger CFM, the better. It will keep from cycling that way, because they do use a couple CFM. Okay, I didn't mention it earlier, I forgot, but there's going to be a test now, midterm. So I need you to think of a tool and a color. Got it? A tool and a color. Now, all of those that did not say red hammer, hold up your hand. Did not say red hammer. Man. Normally, normal people, 98% of the people think red hammer when they're asked that question. I don't know what to think about you guys. I guess I thought red hammer when I heard it. Okay, continuing on. I want to show you how to build the regulator filter assembly that goes into regulating the pressure and filtering the air that goes to the hand pieces. So what you got to look at first is a filter and regulator. And you can have different types. Oops, sorry. Okay. This is a one-piece regulator filter assembly from Harbor Freight. It's under $15. Comes with a pressure gauge, which we'll talk about in a minute. Like I say, it's an integral. You can also do it this way with a separate regulator and filter assembly. Doesn't matter, they work the same. Look at the difference in the filters. You're going to want to preferably what's called a coalescing filter that will help it take the moisture out of the air from your compressor. The filters you see that are white are generally polypropylene or ceramic. They're going to be your better filters. They're going to filter the air to a greater extent. They're going to be around 5 micron or so filtering. Your bronze-centered filters are going to be 15 to 30 micron. The white is better. For these, the holes are large enough, it's not going to really make a lot of difference. So whichever one you get will work fine. Be very, very careful. There are advertisements out there for regulators that are not regulators. An air regulator is going to have a diaphragm in it, and it's going to control the pressure of the air coming out of the regulator. A lot of them are nothing more than a valve that is a flow control rather than regulator. If you hook up one of those to your hand tool, you're going to blow it. It's going to be turning I don't know, million RPM if you put 90 PSI of air into that thing. So be very careful. If it's a flow regulator, you can take it and blow through it. Don't use it. Don't do it. Make sure that it has got a diaphragm type regulator. All right. So first off, you look at your regulator and you've got an input and you've got an output. And the way I do this, and it seems to be about the, already lost it, there it is, about the easiest way I found to do it, or it's easy, but it makes a nice assembly, is to build a wooden, or it could be metal, support assembly, and then attach your regulator and other components to it. But when you attach a fitting, and in this case it's a quick disconnect fitting, same type you get at Harbor Freight, or it's pretty standard size, using Teflon tape, and I never can get this stuff flat, and keep it flat. You wrap the Teflon tape clockwise around your fitting. If you wrap it counterclockwise, it's going to come off and ball up around the threads. So 2 turns. Make sure you don't have any loose ends down there. Look for your input and screw it in. And snug it up. Okay. Now, you've got a pressure gauge goes in the next port. Most of your regulators come with a pressure gauge that reads maximum. It goes from 0 to 160 PSI. Well, you're going to be dealing with pressures in the 30 to 40 PSI range, or actually 30 to 35 PSI range, which is a very small increment in this gauge. So my recommendation is take that off and get you a 0 to 60 PSI gauge. That way your resolution of your pressure on the gauge is much better. You really don't want to overpressure these handpieces. It is catastrophic. I know from experience. Same story with the tape. Now, a lot of people say, "Oh, Teflon tape isn't any good." I learned how to scuba dive back in early 60s. Back then, we used fire extinguisher tanks, bottles, CO2 bottles for our tanks, and we had 1-inch threads, pipe threads on the valves. Teflon tape just came out. We started using them. 1,800 PSI, never had a leak. If you do it right, they're not going to leak. But they're only good on pipe threads. You cannot use the tape on straight threads. It won't seal. And these fittings are all National Pipe thread. These, the input and output is 1/4 inch. The gauge is 1/8 pipe. Question was, are all the fittings on these regulators 1/4 inch? In this case, actually some of them are vary, but generally the input and the output are 1/4 inch NPT pipe thread, taper pipe, and the gauge is 1/8 inch. Like I say, it does vary some with the different regulators, but that's general. Okay, at this point, you need to make a decision either as to what type of valving you're going to use to turn the handpiece on and off. And there's a couple options. The simplest one is you could take what's called a ball valve, like this, and look inside, and you'll see when it's closed, you can see a silver ball, and when it's open, you can see all the way through it. See, this is the simplest way, and I didn't cover it in my handout because it's not my preferred way, but anyway, you can screw that right in there. Take a fitting, it's a pipe fitting, and this again is 1/4 inch, a pipe fitting to a barb, thank you, a barb fitting that'll fit your tubing. Screw that in there. Again with the tape when you do this, and then use this to turn your handpiece on and off. That's all real fine. You could do that like that. There's your whole system if you wanted to. I like to kind of, since I was in charge of customizing engineering, I like to customize stuff. So I usually go a little farther. You can go in now and use a, say, a 90-degree fitting. And I like these push-on fittings. That are swivel fittings, or they make straight, they make T's, all kind of things. And using 1/4 inch plastic tubing. This is the same stuff you can get at your hardware store. This is just PVC. No, this is polyethylene. They make nylon also, which is even better if you have it. But it just pushes in like that, and you're done. There's an O-ring seal inside here. There's little grippers that hold the line in place. If you need to take it out, you pull the button or push the button, and it comes right out. But it seals real good. You don't have to worry about leaks. Okay, from here, most of these regulators come with brackets to mount them. So after you've built your support assembly, mount your bracket, and then your regulator goes in there with a jam nut. Okay, and that part's done. Now the valve that I like to use is called a toggle valve, and it's much like a toggle switch, electrical toggle switch. Flip it up, it turns it on, flip it down, turns it off. This particular one has a barb fitting for hooking your hose to, and has a 90-degree 1/4 inch push button fitting, just like or similar to the one that's up here. There's all kinds of these available. Clippard Minimatic makes a lot of them. There's ones available that are made for dentists that are fairly inexpensive. These on eBay are going to run anywhere from $5 to $15, and depending on the type of fitting, that's about what you'd pay for one. So you mount, if you want to go this way with a toggle valve, which I do highly recommend, it's just kind of nice to be able to just flip a switch and be done with it. Stick the tube in there. Okay, there's your regulator assembly. Now, you're going to be taking in about 90 psi to 100 psi off of your air compressor. You're going to regulate it down to a pressure that's going to be used for the handpiece. And that regulated pressure is extremely critical. If you look at the instructions that come with a handpiece, they're going to say usually about 2.4 to 3 megapascals. Now that translates to about 30 to 32, 33 pounds per square inch. You don't want to exceed about 32 pounds per square inch on these particular handpieces. One, you'll burn out the LED. Two, you'll blow the bearings in them. Now there's a thing called regulator slump, and that's a pressure change going through the regulator that you're going to see, and also there's line loss because of friction in these lines in the valve, which is going to amount to approximately 5 pounds per square inch from the pressure that you have set with the toggle switch or the toggle valve off until you turn it on and the handpiece starts to turn. You're going to see about a 5 psi drop in pressure. So what you want to set your pressure gauge for is around 35 to 36 psi with the valve off. And that will give you a safe pressure on the output. Now, there is another way to check that, and that's with a pressure gauge that's hooked, and we'll talk about the lines later. It's just hooked in line just before the tool. Let's do it on this one. So what you do, this is just a temporary thing, just for checking. But you can take a 60 psi gauge, a little T, a little short piece of tubing, hook the tubing that comes from your regulator here, and there you go, and measure the actual pressure at the handpiece, and just make sure that you've got about 5 psi drop in there, and that you're not exceeding the 32 psi.
Just test that once or...
The question was, do you need to test it more than once, or no? Once you know what the pressure drop is through your system, you don't need to test it again. Now, the nice thing about this is you can also use this for other items. You can use it for airbrush, for instance, just by changing your pressure. Take your hose out of here, run it to your airbrush, and use it for airbrushing. You're done. So your total assembly cost on this thing is in the neighborhood of $30. They sell them for about $140, $130, somewhere like that. So it doesn't take any time to make it. Okay, now then, let's talk about hoses a little bit. One of the, I'm sorry, back to the eBay search. One of the items you need to consider is the number of ports in the handpiece. If you can look right there, you see that has 2 ports in it. One of them is for the main pressure for the turbine. The other one is for the little hole down here that blows, if you're a dentist, it blows a combination of air and water to cool the cutting. For us, all we need is air, and you want a little bit of air coming out of that hole to blow your chips away, blow your dust away. So to get there, we modify a fitting that comes with a hose other thing you need to buy. These hoses are made for dental handpieces. This particular one is made for the 2-hole, so it's got a 2-hole connector. It has 2 tubes. The little yellow one here is for the water that the dentist uses, and the green one for the air. What I recommend doing is getting a hose like this. It's about the only way you can get it. Sometimes you can find just the fitting. Strip the hose out, which is going to look like this. Or you can go and get a silicone hose that looks like this. And there's also information on that on my handout as to what to look for. It's a 4mm hose. I like this. It's being silicone, it's a whole lot more flexible. Now, I also like to not have a lot of resistance in your handpiece when you're using it. I don't like a big hose like this first one I did that uses both tubes in there. So I like to narrow it down to one. And in order to have one hose coming in and have 2 airs coming out, one the main air for the turbine and one for the blowing the smoke away, you've got to modify this piece. And the way I do that is to come in here and I'll drill about a number 70 hole through the outside and into this large chamber. I will then drill about a number 80 hole between the 2 chambers. And that number 80 hole is what the air flows through going to the air outlet for your smoke. Then solder up that hole, and I'll solder up the hole that's left here where the small hose went in. That just gives a little bit of air blowing out of here to help blow the smoke away. Call up those pictures. Okay, there you can see the 2 ports, the large one and the smaller one. Okay, here's where you can see where I've drilled the hole between the ports. I heated the barb on the small one, pulled it out, and resoldered that hole closed so that the air wouldn't flow out of that. Okay. All right. Now, so once you get your regulator made and you get your tubing for your handpiece, it's just a matter of hooking onto your valve, whether it be the toggle valve or the ball valve. Yes. Yeah. No, it uses a little bit of the air pressure from the line that goes to the turbine and redirects just a little bit of it into the little bleed hole.
You're checking the drop. How would you do that first?
Yeah. No, you check the drop. I don't know what the question is. The question was, tell me if I'm wrong. When you drill the hole, are you taking air from the main feed and directing it to the bleed, and whether or not you measure the pressure at the handpiece, the test, before you drill that or after? Is that basically? It's not going to affect it enough, but it needs to be done after because you want to actually know what the pressure is going into that air feed. If you want the pressure at the turbine, true. I think it's such a minuscule amount, though, you're not going to know it. The main thing is, again, you don't want to exceed that 32 psi. You can work with some lower, you just don't want to work with higher. If you work with lower, it's going to affect your torque. Great. Doesn't want to stay on there. There it goes. Okay. All right. I'm set there about 30. I happen to know the drop on this is right around 35 around 5 psi, so I'm set there about 36, 37. I'll turn it on. Okay, compressor cycle. I'm at about 32 psi. And you see the LED light? That's really, really nice. Now, you can, by reducing your pressure, you're going to slow it down. There's 25 psi. And I've found that when this toggle switch is open and this is running, this gauge and the one down here are actually pretty close. And the reason is most of your droop or pressure drop is in the regulator, not in the rest of the hose. So you're not going to see a lot going through this hose that's different than what's here. Now, you can hear that. A lot of people don't like it. It's really not that bad. You get used to it. You also find that these are quite a bit louder than the straight NSKs. Compressor cycled on again. That's what I'm saying. The larger compressor you have, the less cycling you're going to have. Okay. Any questions on building the regulator assembly? Okay, let's go up to the slideshow again. I'm going the wrong way, I'm sorry. Okay, let's talk about burrs a little bit. I'll pass that around. For piercing, there's about 3 or 4 different kind of burrs that you want to use. These are all a 1/16 inch diameter, 0.6 millimeter. It's kind of hard to see there.
Neil, do the zoom on the projector.
Yep.
Tighten it up a little bit.
The one that's on the far left is what is numbered FG.
On the front, on the left, should be a zoom right there.
It's the viewing.
Yeah,
Projector to the right.
there's one more over to the left.
There's 4 of them there.
Yeah, there you go. That one on the far left is an FG169L. FG stands for friction grip. That's what's holding the burr in the chuck. 169 is just the number. L stands for long. That means it has a long cutting taper on it. It is also a smooth cutting area, where these over on the right-hand side you see have serrations in them. 169 is about the smallest diameter. The one next to it is a 170, just slightly larger. The ones on the right is a 700 and a 701. I wouldn't recommend using those with these 45-degree handpieces. They just take a lot of extra torque. That 169L, maybe the 170, but primarily the 169L I like to use on everything. 169 FG 169L. And these are all burrs that I buy mine on. They're carbide. I buy them on eBay. They've gone up in price. On eBay, you can get them for about $1.50 a piece. If you buy 100 of them, you can get them for less. You do break them periodically. I'll talk a little bit about cleaning them here in a minute, but they last a long time. One of these will last, if you don't break it, will last at least for doing a platter like that one, and maybe 2 of them. They like I say, they would last a long time. All right, now with the back to the Dremel. Again, there is a Dremel number 111 burr that is real small, but it still will not do that work easily. You can do it, but it's going to take you a long time. Here, pass that around. Okay, how much time do I have? Let's see here, another half hour. Okay, any questions? I know it's been a bit mixed up. I'll try to get straightened out for SWAT. But any questions at all on handpieces, the 45, the ceramic, the LED, the airflow, the tubes, or the regulator assembly? Okay, great.
Are those parts listed in your, are they listed in that handout?
They're in the handout. Mostly they're, the question was, are the parts listed in the handout? They're all listed there as far as what search criteria to use in eBay generally. Some of it is specific, like the regulator at Harbor Freight, our equivalent type thing. All right, let's go into a little bit of piercing then. Now, before I start piercing something, I always warm up a little bit. So I just take a piece of, in this case, it's maple, sanded down to 1/16 of an inch thick, or milled down or sanded down on a sander down to a 1/16 inch. You can use something like this if you don't have access to thin material. These are just the old wooden ice cream spoons, and you can use those for practice. They're about the right thickness. But like I said, I will start and just warm up a little bit just by doing some just miscellaneous. 25 psi just doesn't quite happen. The other thing I use is a magnifier. The other thing is some air. This is a little fan I got at Walmart, $7. This does make some smoke, and that blows it away. Otherwise, you're not going to be feeling too good after about an hour of inhaling smoke. So do that for a few minutes, just to kind of loosen up your hand. But you don't normally, not normally, if you're going to have patterns like I do with the butterflies and that type of thing, you've got to have a pattern to transfer to your workpiece. If you go out and look on the internet and do a Google search for, say, butterfly coloring book, or butterfly image, or butterfly line art, or flower line art, that type thing, there's hundreds of different images that you can download. There will be outlines, that'll be line art, whatever type thing. You need to take those and transfer them to a drawing program of some type that you can trace them, or that you can resize them, depending on what it is, that you can copy and make multiple images of it. And using a program like that, you can make a pattern, something like that. Now that's printed on a laser printer, black and white laser printer. I have a color, and I found out the color printer just won't transfer the ink or the.
Under the camera here, we'll put it for you.
There you go. So, like I say, the image won't transfer to your wood off of my color laser for some reason. Why, I don't know. Also, you can go out and you can find images of various things all over the place. This was and I didn't print it in color, but there's I did. Yep. Yeah, I'll show that in just a minute. Okay. You can find images all over the place if you just look. This is one in the theater on the Disney cruise liner that I took a photograph of. I thought it was going to be a nice image to transfer over rows and use it for piercing. So I took the image, put it in a drawing program, and traced it using the tracing function of the program, and that didn't work too well. So I hand traced it using the pencil capability of the program. And then that gives you this pattern. From that, you can size it to virtually anything you want. And I'm using a program called Draw Plus version 8. And it's a really nice program. It's a little bit expensive now. It's $100 and some odd, but there's a lot of other programs that are, I'm sure there's a lot of free ones that you can do that with. Okay. Once you have an image, either printed on a laser printer, or you can take it and have it copied on a Xerox type copy machine. You take it and cut it out to whatever you want to put it on. I'm just going to take one section here. Take it and turn it upside down. Now remember, the surface that you're transferring this to needs to be your final surface already sanded. It won't transfer to a rough surface. So I usually sand to 400 grit. And tape it in place. Now when you have a compound contour like that, or sloped contours, you have to do some monkey motions in here to get them to fit. Monkey motion. In the case of this pattern, it's going to go on in a bowl that's going to be sloped inward like this. You measure the diameter of the outer ring. You measure the width of your flat. You don't measure the inside diameter. You measure the outside diameter and the width of the flat. You subtract twice that flat diameter from your outside diameter, and that makes your inside one for the layout purposes. Got that? No, you don't. Remember, you're going in like this. So if you just measure this inside diameter, it's going to be too small. You've got to measure your outside diameter and the flat part where your pattern is going to lay, that width, and then you're going to basically flatten it out like that. So this inside, you really don't need to lay that out if you don't want to. You can take your outside diameter and your width of your flat and just use that for your pattern width. When you do lay it in the contoured part, you have to come in, cut out the outside to fit, cut out the inside, and then cut some pieces out like this to allow it to warp around the contour, that type thing. It's just a matter of fitting it in there. Okay. All right, now to transfer the pattern, I use a chemical called xylene, or Xylol, Xylol. You can get it at any paint store, Ace hardware stores in the paint department. Yeah, it smells. You can use acetone. Acetone works fine. Xylol is a little bit more forgiving maybe than the acetone is, because it does dry slower. But you can get too much on here very easily. So what I do, I take a paper towel, fold it up, take a little paper towel, get the xylene on there, dab it on my paper towel and just kind of get it a little bit damp. And then just kind of lightly lightly rub and dab the pattern. And remember, you've turned that pattern over so that the ink is on the inside. Against the wood. You got to be real careful here. If you get too much of the chemical on there, the solvent, you're going to lose your transfer completely. It'll just wash it away. If it matters, yes. The question was, when you do your image, it needs to be the reverse image of what you see on the computer screen, because you're turning it upside down. I mean, if you're looking at the image on the computer, and you want, say, a bird to be facing left on your piece, you're going to want it to facing right on your computer screen when you print it, because you're taking the printed image and you're flopping it over upside down, and it'll be facing the wrong way. So once you get this image transferred like that, hopefully it came off. Yep, pretty fair. There's your image that you're going to pierce.
You said you wanted that wood sanded to 400 to finish? You want your final finish on there as well?
No, this is before finish. You don't do any finishing until after you pierce. Good question. Did I ask what your question was? Okay. That's easy to forget to do, I'll guarantee you. Okay, one other thing I do is I usually take and put a hand towel down. When you do piercing, it has a tendency to blow little chips, black stuff all over the place. And this kind of catches some of it. It doesn't catch all of it. So, I lost my green tape there. Okay, this particular image has a couple of things. It's got an outline, and then it has some cutouts. When you make the outline, you've got to remember to leave some little gaps in it, or it's going to fall out. Your whole image, your whole piece will fall out. So you got to have a little bit of support structure in there to hold these. It doesn't take a lot, but they've got to be there or else. So you can come and start in here, leave a little gap. I know watching somebody pierce just like watching paint dry. So I'm not going to do much of it, but now that's the way you do the outline. The area that you're going to do the cutouts, you do a little differently. One thing about doing the outline, but primarily the cutouts, is the direction that you travel. Found it's a lot better if you do it clockwise. And the cutter, the question was which direction the cutter turned. Looking down on it, it's turning clockwise. Looking at this end. Making the cut clockwise seems to be easier. Now, once you've make that cut, you'll see that there's burned area all the way around it. If you go back and go counterclockwise very lightly, you can clean up a lot of that burned area. Now, I found out you may want to leave that burned area, may want to leave it black, but if you don't, you can go back in, like I said, and go counterclockwise with the tip of your tool and clean a lot of it out. Okay? This? Well, normally you've got a whole bowl or something like that you're doing. So, no, I like to have a good grip on it. Yeah. Not necessarily. I just kind of work whatever feels good and do it. Yeah. But again, it's just, Pete, do you always do it clockwise? Oh, sorry. So you can see that's about the way that one goes. Now, I want to quickly show you the difference between that and the NSK.
Lynn, I have a question.
Okay.
When I tried to pierce, I go crooked. I mean, it kind of looks like a slant. How do I keep that?
You mean,
You know what I mean? The cuts kind of,
so you're not going in straight, you're going in like this.
maybe so.
Yeah, but that's what it is, and it's easy to do. The question was sometimes when you pierce, your cut is a little bit at an angle. It isn't perpendicular to the face of your wood, and the reason is your tool is not going in perpendicular to the wood. That's the only thing, and that's something that you get with practice, is getting that perpendicular. Man, I should have tried this hose before I left. Like I said, you can make any kind of regulator you want. This is mine. It has a regulator like this inside. It has a filter similar to this one out here. Has a toggle valve, and it has a quick disconnect. This is a little disconnect which is similar to these big ones. Same thing, only smaller version of it. If you look on eBay or other places, they have ones that are made for airbrushes, and they also have ones that are better than that are made for paintballs, guns. Boy. Yeah, that's sort of hooked. Okay, I was going to show you this quickly. This is the $400 NSK handpiece. Oop, just lost my air. I don't know what the deal is here. I guess it's a wrong fitting. I'm glad I found this out before SWAT. Excuse me just a minute. Yeah, I do, but it shouldn't make that much difference. That's the way it's supposed to work. Okay, I'm anywhere close.
Oh, yeah, you're right there.
All right, first off, makes a lot less noise. And it is much more powerful. But it costs 8 times as much as the other one does. These are nice, but for starting, I would highly recommend one of these. That way you're not into the system for a whole lot of money. You find out if you like to do it. They work well. I really like the LED light. Presto now has one with an LED, and it's $500 or $600. It's ridiculous. The turbines for these you can replace for under $20. This one's $160. All in all, if you're not going to be using it very much, highly recommend using that 45. The 90, like I said, is very difficult to use, and there just isn't any straight ones available on the market for less than the $300, $400. Okay, your burrs do get dirty, and they can be cleaned. This is a piece of soft steel, 1018, 1020 steel. It's a key for a keyway in a shaft for a pulley or something. But you can just take, and when it gets dirty, gets the carbon on it, you can just take it and wipe it across that steel. If you're careful, if you're not careful, you'll break it. It'll vibrate and it'll break. But that pretty well cleans the burr, and you can go on and do some more piercing. Do what? Yes, I have. The question was, have I ever punched that into my hand? Yes. You can do it, so you do need to be careful. I'm talking about piercing wood here now. I'm not talking about body piercing. You can. Yeah, but it does get blood on the wood. So basically that's what you're doing, and like I said, I'm primarily would like you to, if you're interested in this, this is a cheap way to get involved. Once you build this, it'll run this just like this one does. It'll run your airbrush, any of those air power tools like that.
And your cleanup after you've done.
Okay. Question was about cleanup after I'm finished. Okay, first off, like I told you, I go around counterclockwise, and I found that after you do the clockwise cutout, if you do several of them, and then go back and do it, it seems to work better. I don't know whether it's still hot or what, but after you let it cool off for a minute and then go back and do the counterclockwise, it cleans off easier than it does if you do the counterclockwise immediately. Okay, cleanup. There are a neat little rotary Scotch-Brite radial bristle disc that look like this. And you put them on an arbor. And this is where your micromotor comes in handy, or your Dremel. Ooh. Got turned on in the bag. Once you're finished with your piercing, you can come in with the little radial disc sanders and just go over it like that. And then do the other side. Now the other thing this does, generally when you do the piercing, you're going to leave some of the lines that you transferred off your pattern, and this will take them off. You just sand them off. There's various grips. I usually use the 220, 180 or 220 grip. Sure picks it up in the mic, doesn't it? So, pretty well cleans it up. Now, sometimes I'll go back, depending on what it is, and kind of go over it real lightly by hand with some 400 grit paper, but generally I don't.
What's the limit of thickness that you can really affect?
With these tools, probably 1/10 of an inch. After you get up any thicker than that, they start loading down real quickly. Now you can make multiple passes. You can make a pass, go back, make another pass, just hog your way through it. It just takes time. If you're going to be doing thick work, then I would probably drop back to the Dremel or a Fordham type tool with a flex shaft and a cutter like that 111 Dremel cutter there that's passed around. Okay, I think I covered it in a roundabout way. Okay, let's look at this. Talking real quickly, talking about patterns that are available. This pattern was a Linux candle holder, about that big around, and it had that pattern cut out in it and pierced out of the candle holder, and it's Linux porcelain. I took a piece of paper, stuck inside it, and I had some silly putty, essentially, crammed it down in the inside, pushed the paper out against the edge, traced it with a pencil, pulled the paper out, scanned it on the scanner, so I had an image of the outline. I went in and, again, traced it using the drawing program, and that gave me the section this big. Copy, paste, another section next to it, copy, paste, another section, copy, paste, another section. So I had them all strung out, grouped them together, and printed them, wrapped it around, transferred the pattern. Now this piece I got too thin. It's about instead of 60 thousandths, it's probably 20 thousandths down here. So it cuts real easily. I mean, but there's some other area up here that's almost a tenth of an inch thick. I just really didn't do a good job turning this. I did cut it earlier with this tool, and I could do it. Some of it I had to make 2 passes on though to do it. So, limit, I would say, somewhere around a tenth of an inch with this tool. Okay, any other questions? Okay. All right, thank you very much.
All right, let's take 10, 15.